Welcome to AI Frontiers. Today's episode explores the wisdom revolution in artificial intelligence, synthesizing insights from 99 research papers published on September 29, 2025. This snapshot reveals a field-shifting focus from merely building smarter AI to creating wiser, more reliable systems that bridge the gap between raw capability and real-world trustworthiness, driven by rapid innovation from the global research community. Today's journey through AI research examines what happens when artificial intelligence learns to doubt itself. By exploring 99 papers from a single research day, we witness the evolution from problematic hallucination to emerging self-awareness in language models. Efficiency breakthroughs are enabling wider AI access, while real-world applications increasingly demand trustworthy, reliable systems that can operate safely in critical domains. The field of computation and linguistics represents the ongoing quest for human-level language understanding. This domain has evolved from 1950s rule-based systems through 1990s statistical approaches to today's neural network revolution. Current research focuses on large language models as digital brains, while addressing persistent challenges including computational cost, hallucination tendencies, and language bias. The ultimate goal remains creating systems that can process, understand, and generate human language with expert-level nuance and reliability. Theme 1 focuses on scaling and accelerating inference to make artificial intelligence faster and more accessible. Bao and colleagues introduced learning to parallel, accelerating diffusion-based large language models through adaptive parallel decoding. Zhao's team developed SEM-Share-KV, reducing memory requirements by sharing computational caches for semantically similar prompts. Young and collaborators demonstrated ultra-fast language generation, distilling high-quality models into lightning-fast versions without significant performance loss. Energy efficiency is becoming increasingly critical for sustainable AI development. Theme 2 emphasizes enhancing reasoning and correctness, moving artificial intelligence from merely sounding smart to actually being correct. Chen's team developed RFG, improving reasoning trajectories in diffusion models without requiring separate reward models. Ma and colleagues argued that models need critical thinking capabilities beyond simple faithfulness to source documents. Wang's work on calibrating verbalized confidence directly tackles the problem of model overconfidence. These approaches advance AI safety through improved self-awareness and accurate uncertainty quantification. Theme 3 addresses specialization for real-world impact, creating artificial intelligence that actually helps in critical domains. Dang's team developed NoGuard, providing medical AI systems with systematic abstention capabilities when information is insufficient. Gong and colleagues conducted comprehensive evaluations of software agents, assessing both medical knowledge and empathy communication skills. Jiang's work on incentive-aligned multi-source summaries creates frameworks resistant to misinformation. High-stakes applications increasingly demand specialized, reliable AI systems with domain-specific expertise. This technical deep dive examines diffusion language models and their any-order generation revolution. Unlike sequential models that generate text word by word, diffusion models begin with fully noisy text and iteratively clean it up through denoising processes. This approach provides powerful generation capabilities but presents challenges for step-by-step reasoning guidance. Chen's reward-free guidance method enables effective control over diffusion model reasoning without requiring separate reward models, making these architectures more viable for complex problem-solving tasks. Key findings from September 29th's research are redefining artificial intelligence progress through 4 major breakthroughs. Zhang's team demonstrated that models can self-improve during inference through frameworks like latent evolve. The NVIDIA consortium successfully pre-trained large language models using 4-bit floating-point precision at scale. Zhao's work showed that smaller models can achieve strong reasoning capabilities with quality data curation. Wang's research revealed that incorporating self-doubt mechanisms creates more honest confidence scores in language models. The methodology toolkit behind these breakthroughs includes several established approaches. Reinforcement learning from human feedback optimizes complex goals like safety and alignment, though it requires significant computation. Preference optimization trains models directly on pairs of good and bad responses, providing more stable training. Retrieval augmented generation grounds models in external knowledge. Sources to reduce hallucinations. Knowledge distillation enables efficient deployment by having smaller student models learn from larger teacher models, balancing performance with computational requirements. The selected paper by Chen and colleagues introduces reward-free guidance for diffusion large language model reasoning. The core problem addressed involves the difficulty of guiding diffusion models through step-by-step reasoning processes. The key innovation uses the model's own enhanced version as an implicit reward signal, eliminating the need for separate reward models. Experimental results demonstrated accuracy improvements up to 9.2% on mathematical and coding benchmarks. This work significantly enhances the viability of diffusion models for complex reasoning tasks requiring structured problem-solving. Feisel's paper on multilingual alignment addresses the artificial intelligence equity gap using semantic rewards. The fundamental problem involves the limited transfer of reasoning skills across different languages due to data disparities. The solution employs high-performing English models as expert pivots, with rewards based on semantic equivalence rather than direct text comparison. Results showed multilingual performance improvements averaging 16% across evaluation benchmarks. This approach provides a scalable blueprint for transferring advanced AI capabilities globally, promoting more equitable access to language technology. Wang's research on confidence calibration teaches artificial intelligence to recognize the limits of its knowledge. The core problem involves model overconfidence, where systems express high certainty even when providing incorrect information. The key insight identifies suggestibility as the underlying mechanism driving overconfidence in uncertain contexts. The DINCO method uses self-generated distractors, plausible but incorrect alternatives, to normalize confidence estimates. This approach has critical implications for safe AI deployment in high-stakes domains, including medicine, law, and financial services. Future directions in computation and linguistics point towards several emerging frontiers. Self-evolving models capable of adapting their reasoning processes post-deployment represent a major research direction. Hybrid AI systems that orchestrate multiple tools, databases, and verification mechanisms will provide more grounded responses. Personalized assistance understanding individual user needs and contexts will become increasingly important. Navigating the complex legal and ethical implications of advanced AI systems at scale remains a critical challenge for the research community and society broadly. This AI synthesis and review was created through comprehensive content generation processes. Content synthesis utilized GPT and deepseek-chat models for initial analysis and organization. Text-to-speech generation was performed via Deepgram's neural voice technology. Visual concept design employed StableDiffusion for complementary imagery. Human expert review was conducted throughout to verify technical accuracy and contextual relevance. Potential oversights are acknowledged despite careful review processes and multiple validation stages. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.